Focus camera. There you go. So here I got to use, of course, what? Product and chain. I like it. So 2y e to the xy plus, I like xy squared e to the xy. Is everybody cool with that? Because y is acting like the variable, so x is going to be the constant in relation to that. And then what's dq dx? It's the y part, so it's already derivative with respect to y, is what I'm assuming, and now I'm going to see what its derivative with respect to x is. Okay, I like it. Yeah, so now I can use, I could distribute this first, but I don't care. I could do the inside here, 1 plus y, leave this guy alone, plus 1 plus xy. Derivative of this with respect to x would be y times it. I like it. Now I got a little cleanup so I can compare it. Oh yeah, you're right. Thank you. So now I've got to clean it up a little bit so I can compare it to this guy. So here I get y e to the xy plus y e to the xy. So I get two of those. And then xy squared. So are they the same? Yes, yay.
Is that the same as checking for exactness? And
yeah, there you go. I like it. So you can kind of make some connection now between the two ideas, but I don't want to get too deep into it because some of us have not taken DiffQ in here. When I say us, I don't mean me. I've taught the damn thing. So we know then what? What's true? Tell me. It's conservative. Also, we know there must exist a little ass f, right? So that the gradient of it would be this. So, okay, so this is just to check to see if it's conservative, and it is. So if I went around the curve, if I integrate any curve that comes back to itself, and it meets the requirements set forth earlier, then it's going to have to equal 0. The integral of that across there is going to have to equal 0. Or if I want to go from point A to point B, it doesn't matter how I get there. I can create the simplest way to get there and then integrate that, and I'm guaranteed to get the right answer. That kicks a lot of ass. Hopefully. So how in the world do I figure out? So if this is true, we just figured out that it's true that f must come from delta f, which means that this piece must equal what?
The partial.
Yeah, the partial of f with respect to x. So now I'm going to do this like partial integration. And this is the part that gets a little bit weird. Because normally when you integrate in 180, what was the mantra? You had to repeat yourself so you didn't lose some stupid points. Don't forget the plus c. Exactly. Don't forget the constant. Right? Here, constant is going to be not just c. It's going to be
a constant function.
a function of
X. Or no, Y.
y. I like it. What is the constant here? Y is. Because it's partial with respect to x.
Also, you're going to have some overlapping terms, aren't you? In the two?
That's the, thank God. Yeah, well, let's watch. So if I integrate this with respect to x, partial integration. So realize I'm only integrating e to the constant x. That's all I'm doing. How do I do that? Exactly, divide by the y that would want to come out. You could use u sub if you had to, but I'm hoping you don't have to. You should know integral e to the ax is e to the ax over a. That kills the a that wants to go. Oh, my sake. That kills the a that wants to come down. Right? Kill it. A lot of u sub you can just think of just killing the part you don't want to have there. Just kill it before it even gets a little assassin waiting. Plus, no, not c, but it's going to be. Yeah, and we already got enough freaking f's, don't we? So let's use g. I like it. So that is acting just like the plus c. But now, what's a constant related to a partial with respect to x? A constant would be any function of y. So, and what is this got to be? Gather. That's going to be what? That's fy equals. Let's go ahead and distribute this. And I know what f is. I know what it is. Just like in algebra, I know how long the shed is when I say it's x meters long. I know it's x, but now I got to do a little work. So I know what f is. It's this. I just got to do a little work to really find out what that is. So what can I do then to connect the two?
Take the partial derivative.
Yeah. Take the partial of f with respect to y. And of course, this is just going to be that. Is that cool? All right. So to take the partial here, I just got to do I got to do a product rule.
Use the xy.
Yeah, e to the xy.
Y squared. Sorry, xy.
Yeah, xy
E to the xy.
plus
G prime y.
g prime y. I love it. Gotta like being able to bring the prime back. Did you miss prime? Oh, poor little prime. And like Ben said, there's overlap. Now here, this is one of the least interesting examples, but oh well, too bad. I just happened to pick this one. G prime y must equal 0. Now, if there was a plus y here or a plus whatever, then g prime of y would equal it. And then how would I figure out what g of y is? I would integrate. Like, so g prime of y must be 0, which means g of y has to be a constant. I love it. And the book likes calling him K, but you can bring back big ass C if you want to. Now, why do you think the book doesn't use big ass C? Because I haven't written it down here anywhere, but where's the little C is the region, the curve around which. So that's why the book likes to use K nowadays. So what's my little F dude? The little F dude would be, where'd it go? Here we go. Y e to the xy plus some constant. Crazy. Do you guys get a feel for that process? You could do the same process, believe it or not, with 3 dimensions. You've only got 2 dimensions up here.
Can we do that? An example?
Okay.
So is that little f basically the second partial with respect to y from f of x? Is that where you got
This
that?
here?
Yeah. Right there.
No. This is actually the opposite of this. This is partial integration. We got from here to there by integrating this with respect to x. Because how did I get from f to this? I differentiated with respect to x, and I'm going to integrate with respect to x, treating y as a constant. I like it. That's why it's called partial integration.
I think I'm just messing up. How did you get xy e to xy for the FYI?
Oh. So right here is my function. One of these y's cancel, right?
Okay.
So it's going to be derivative of y is 1, e to the xy. And derivative of e to the xy is going to be x e to the xy. X is a constant.
That's the y. Okay.
Yeah. I like it.
Would 3 dimensions be like a 2-step process? Like if you had z and then you derived it.
3 dimensions, whatever you pick to do. Now, do you guys realize I could have started here, integrated with respect to y, and then went back this way? So in 3 dimensions, you have
2 steps.
several different ways you can go.
Your first constant will be like a g of xy or.
Exactly. So instead of gy, it's going to be g of xy or g of yz or whatever you picked to do first is going to be the other
So
2.
then you get g prime of x y, and then you would set that equal to what exactly? Whichever
Well,
one you
whatever
pick.
overlaps in the other one. So let's do an example. How much more do I want to do? I want to do a lot more. Well, let's do one more thing with this before I get too far. No, maybe not. Oh, here we go. All right, let's do this. I'm okay with this. We can do this. All right. So we got what they want from this? More than you wanted? So semi-quickly here. Now here, what gets interesting is, now I've got like P, Q, and R, right? So let me see if they give you, blah, 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 blah. Oh, do they even tell you? Oh, they didn't tell you what to check. That's horrible. Well, I think that comes later. Oh well. So right now, they've told us this is conservative. told us. I think later in this book we actually are introduced to how to check that. I want to find f so that delta f equals big X. Right, so that's just like we just did. So I've already told that it's conservative, so I don't have to check that. I don't have to do the second derivatives of these things. In fact, you might start to realize exactly what would that entail. Which second derivatives would I do? I could just jump right into figuring out what this is. This is going to have to be, if there is an f, this is going to have to be what? Fx equals yz. Fy equals xz, and fz equals xy plus 2z. All right, so then you can start anywhere you want to. It doesn't really matter where you start. Doesn't really necessarily make it any easier to start with when an easy one, but it doesn't matter. Which ones you got to start with?
So fx,
It's fx, I like.
x, y, z,
So then f must be,
x,
that's crazy, xyz.
plus g of y, z.
All right, so everybody understand that little g dude. All right, I like it because x is the only variable when I'm doing this, so the constant would be a function of y and z, the two variables that we're treating as constants. I like it. And then I can compare it with this guy by doing
Partial of f. I mean, of y.
fy. Oh, this is another not so interesting one, isn't it? Let's do this. Let's do fz. What do I get when I do fz?
X, y, plus g, y, z.
Well, let's be careful with that. Why do you think I've got to do that?
Well, because it's a partial of z.
It's two variables in there in a way. Yeah. And if I compare that to that, then I see what's got to be true. If I compare these two, gz has to equal 2z. I like it. GZ, that sounds like a rapper or something. GZ equals 2z.
It's pretty close. It's pretty close.
And so what's G equal? G of yz equals
Z squared.
z squared.
Plus a constant.
Plus.
H of y.
Yeah, because what's considered to be the constant here?
Y.
Y. And then Ben says, well, let's just keep going with that. The path you've set up. We'll just use H for this one. Make sense?
That's just K. Is that what I'm saying?
Well,
But yeah, we're gonna, yeah, exactly. Now, if you do, now what's the only thing left that I haven't looked at yet? I used fx to even come up with the first form of this. And then I used fz to get closer to it. And now I'm going to use the only one I haven't used yet, fy.
so now you plug that.
So what is, where am I at now? Let me write what f is. F is going to be xyz plus z squared plus h of y. So fy is xz
Plus 0.
0.
Plus H.
Y.
And like whoever, I forget who said this, h prime of y, if you compare it to fy, h prime of y equals 0. So h of y equals okay. I like it. Yes, sir.
I got pretty confused after you set them equal to each other. You just did algebra from
Here?
No,
So you're cool through here?
to there, yeah, and then
And now I integrated with respect to z.
okay, you integrated. Okay.
So z squared plus a constant using y, because y is known to be the constant here, right? I like it. And then I've got now I'm going to rewrite f in terms of what I know so far. This is less unknown now. I've got it one thing known now, and I just got this one last piece that I don't know. And then I do the process again using the only one I haven't used yet.
Yep.
So it wouldn't really matter at all which one you started with. You do the same. It doesn't matter where you go next. Truly, yes.
So you're saying that g of yz from the little f right there is equal to the z squared plus hy.
I love it. Yeah, that is there. And then I can do stuff to this guy again and compare it to this guy. So I keep like stripping away this unknown. This is like an unknown of two things. Now I stripped it away to an unknown of one thing. And then I can go one more step and get it known completely.
Are you doing the same thing as solving for a separable
Yes.
Yeah, exactly. Yeah. We just don't call it that here for.
Why is that z squared 0? When you
Respect to y, so z is going to be a constant. I like it. Cool. Yes.
This is kind of like, I mean, it's not unrelated, it's related, but it's a kind of weird question. Is there a word to say a variable that we're holding constant, besides just saying it's a constant? Because there are constants that are like 3.
Well, I mean,
There are
people have thrown away.
constants
I
like
hate saying constant variable. I've heard people say that, but that just is really silly to me. It's almost impossible to get the right idea across quickly. We're holding this variable constant. That makes more sense. I can do that. I can control a variable, but it has to have multiple possibilities for its input. So it can't be a constant variable. That sounds weird. Bless you. I don't think we've come up with one. So there's a lot of mathematics just waiting for new blood to come in and say, what the hell are you guys doing? Just call it this shit. Oh, okay. Just call it GZ. All right. I'm going to have to compromise with myself a little bit. That so sucks. Oh, my gosh. I'll tell you this. I'm going to talk about 16.5 right now because that's almost impossible to figure out which one's more important between 16.4 and 16.5, but 16.5 is freaking important, so that we're going to do it semi-quickly. In fact, it's going to be remarkably quick just to lay the groundwork down. So this is 16.
Just skipping greens.
Skipping greens for the moment. I'm not going to be able to let that go. Now, if I write this like this, can you see how it's an operator? This is an operator. And again, if you've taken Diff Q, you're talking about differentials themselves as operators, big ass D, if you've taken differential. If you haven't, I'm sorry, I keep talking about it. You know, like, what the hell? So go take it. But I can see how this is kind of like waiting. This is open. This is empty space. So I can operate on a function and fill it in. So we've already done that. And this, when I operate on a function, that's the gradient. And that's exactly what I would get, right? If I threw an f in there, I get the gradient of f. Crazy. But now I can define these other things. I can define this, for example. And if f is my thing that we introduced earlier, p I hat plus q, j hat plus r. You can imagine that. K hat. Can you see what would it take to do this? This is a bit like just the cross product from before. Whatever way you have, if you write the matrix by itself, or you've memorized the cross things, or whatever. You guys understand? You've already got some process, hopefully. Or else you got through the earlier part of the semester. Blind luck, I don't know. Gotta be a way. This we call the curl of f. And very quickly, the curl is a... what do you think would happen here? If f was conservative, so that there existed a little ass f, what do you think would happen here? What is somebody help me out? What's this?
0.
0. So this is going to be
0.
0. And for much the same reason, those are going to be pointing in the same direction. So the curl is going to be, the cross product is going to be 0. So what's interesting is, if I had a vector field, can somebody tell me this very quickly, is this a conservative vector field that I've drawn so far? So you can imagine it kind of keeps going like that
No.
forever.
No.
Hell no. Why can you say that so quickly? And
Because you can go in a circle.
I can find a path very quickly where the integral across that path would not be 0 the way it's supposed to be. So that kind of question should be answered very quickly. There's a problem like that on the practice test. Would you say that if I drop something here, would it want to go in a circle?
Yes.
Yes. Okay. So the curl is a little more than this, but it's a decent way to kind of explain it. It's a measure of the total circulation. that the vector field that that it tries to impose, or that you experience if you're a particle traveling through this. Are you experiencing any forces trying to make you go in a rotational, in a circle, right? If so, then there is going to be a non-zero curl, right? Maybe. So, and the bigger the curl is, the more tight, the more powerful that circulation is. So the curl of a whirlpool. Now I've got Pirates of the Caribbean in my head for some reason. Remember that? If you haven't watched it, I'm sorry. Take the cue, watch Pirates of the Caribbean. That would be pretty strong, right? Whereas if I just went like this in the pool and there's a little something, that would be pretty weak. I mean, you guys kind of with me. It would be a small curl versus a big curl, and zero means no rotational aspect to it at all. This is one way to have a non-zero. So hopefully you guys understand. Please understand. This would not be zero. Is that cool? Because it's obviously wants something to rotate.
If you imagine the z-axis to be there, which it is, but if you imagine it coming out, curl would represent
Okay, good.
only a
Curl, if you'll notice, curl of f is going to be a vector. So it does have a direction. I like it. Let me see if I remember the direction. Shoot. I think if it's going counterclockwise, it would come out of the page. If it's going clockwise, it would go in. All right, that sounds familiar. It's been a long time. Yes? Yeah, exactly. Torque is an application of cross product. Anytime you take a cross product, it's going to have a normal to the plane direction, right? So this is just a cross product. It's going to have all the same properties of other cross products. It's just a little weird because this guy has got differentials, derivatives in the components instead of, actual numbers or whatever, or functions. All right. Damn it. Divergence of f is that. That's the divergence of f. And the divergence of f is really cool. If the divergence of f is positive, that means there are things emanating from that point. So if I take the divergence of a vector field at some point and it's positive, that means that whatever is happening, if it's electric field, magnetic field, if it's bananas coming from a banana producing machine, right? And if I take the divergence, then it's negative. That means that's the person taking the bananas in. So positive divergence is where it's coming from. It's the source. Negative divergence would be a intake. And zero divergence means whatever's coming in is also just going out, which I guess you could hopefully at some point, unless I'm in big trouble, it's gonna happen. Yeah.
Like the top or bottom of a mountain. So that would be like top of a mountain, bottom of a pit. Would have the divergence.
Oh, okay. I'm with you when you're talking like a gravitational, or no?
Yeah. Like if you have a common gravitational path, right? At the beginning, the gradient is going away in every direction.
Oh, I'm with you. Okay.
You're getting it.
It's not. Well, I got to play with that a little bit, but it could be possibly related to something like this. Matt. Yeah. The curl is a vector, so you can define. Yeah. So negative is weird because when you have 3 dimensions, what do you call them negative exactly?
So back to like 0 like that, you have the same lines going in as you do coming out.
Oh yeah, if you had it enclosed. Yeah. And Matt. Depending on the rotation direction, then you can think about it's going to either be pointing out or pointing in. So you can think of that as being positive or negative. Yeah, depending on the direction of rotation. Okay, thank you.
Okay, so just double checking. Homework all the way up till the